Fuel, oil and lubricants, and their effects on combustion engines. Every time an engine is run, deposits are left behind, and these always have a long-term effect on the way the engine functions and its degree of efficiency. In particular, compression is reduced as a result of sediment in the area of the piston rings, oil rings, and their grooves. The deterioration in the combustion of the fuel-air mixture resulting from this leads to a reduction in the engine's performance. As a result of this, there is an increase in both oil and fuel consumption. This creates a situation where the sediment caused by the combustion process increases markedly, exhaust fume levels rise, and not least, the wear and tear on engine parts escalates. Parts of the mixture and combustion gases evaporate in the crankcase and thereby accelerate the speed at which the quality of the oil deteriorates. And this can lead to problems in the crankcase breather system. Larger particles of dirt, such as the formation of resin deposits in the oil ducts, can trigger a reduction in the lubrication of important components, for example, the camshaft. Are all these impurities removed by a normal oil change? To illustrate this, let us have another look inside the crankcase. The old oil is drained during the simple oil change process. However, not all the impurities caused by running the engine are removed when the old oil is drained off. Some of them remain in the form of deposits in the oil and the lubrication system. Once the engine has been refilled with fresh, clean oil and is then started, the new oil absorbs the remaining deposits, and in a very short time, the oil is once again contaminated. This situation naturally has a negative effect on the efficiency of the new oil. In order to maintain both the performance and the economic efficiency of combustion engines, we recommend that the complete oil and lubrication system is cleaned before each oil change. After our cleaning agent has been added to the old oil, the engine is run in idling mode for 10 to 15 minutes. During this time, it releases all the impurities caused by running operations in very fine molecules, as shown here at individual problem zones. In our example, this is the piston ring area, the crankcase breather area, the camshaft lubrication area. At the same time, highly efficient lubricating substances protect the engine during the whole cleaning process. Elastomers, such as oil seal rings and O-rings, are kept absolutely supple. All the impurities are now removed when the old oil is drained. This means that the oil and the lubrication system, which we fill with new fresh oil, are kept very clean. Now, the new oil can perform to the best of its ability in a clean environment and fulfill the tasks required of it, such as lubricating, sealing, cooling, purifying, and keeping particles in suspense. The fresh oil is now able to absorb the impurities that have been newly created and is no longer limited in its ability to perform by the old deposits. As a result, we have new, fresh oil in a clean engine, the best possible oil and fuel consumption, improved engine performance, less wear and tear on parts, the lowest exhaust emissions, and a longer life for the catalytic converter.